This lesson is on basic rules of exponents. So let's remind ourselves what x to the fifth power means. That means x is a factor 5 times. X times x times x times x times x. So if I want, for example, x to the fifth power times x to the third power, that would give me x times x times x times x times x. That's x to the fifth multiplied by x to the third power, x times x times x. Rewriting, all I would have is x times x times x times x times x times x times x. That's x written 8 times, or if you like, x to the 8th power, which of course indicates a rule. What did I do to the 5 plus 3? I had to add them together. So if I have x to some power, x to the m, times x to the n, I'm just going to go ahead and go with x to the m plus n. One more example of that. Let's say I have x to the third times x to the 7th. If I want to multiply it all out, that'd be x to the third, x times x times x, times x to the 7th, 1, 2, 3, 4, 5, 6, 7, which is x written how many times? Which is x to the 10th power. So again, using that rule, x to the 3 times x to the 7th is x to the 3 plus 7, which is x to the 10th. And I could even do one with much larger numbers if I want, for example, x to the 300 times x to the 104. Well, again, that would just require me to add the exponents, x to the 300 plus 104, which is x to the 404. But in your mind, I want you to see 300 x's and 104 x's for a total of 404 x's. So again, our rule, if you're multiplying with the same base, x to the m times x to the n, the result is x to the m plus n. Same base, add the exponents. But now what if I do this? What if I do x to the third to the 4th power? What does that mean? Anything to the 4th power. Brackets to the 4th power means multiply the brackets 4 times together. 1, 2, 3, 4. But what's in the brackets? X to the third. So the brackets are written 4 times. And what does that mean? That means x, 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 x. How many x's is that total? That, of course, is x to the 12th power, which indicates another rule for us. If I have x to the m all raised to the n power, that requires us to multiply our exponents. Like you saw here, 3 times 4 is 12. That's going to be our idea. Looking at another example of that, if I have x to the 5th raised to the 3rd power, that's going to mean x to the 5th written 3 times. That means x to the 5th times x to the 5th times x to the 5th, which means x, 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 x times x, 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 x times x, 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 x. How many x's are there? X to the 15th power. And again, to shortcut the rule a little bit, x to the 5 to the 3rd power is the same as x to the 5 times 3. But try to remember what it is representing. Now, what is the next thing that we'll talk about? We'll talk about something like x to the 6th divided by x to the 2nd. And what is that going to give me? Well, again, we ask ourselves, what does that mean? X to the 6th, 1, 2, 3, 4, 5, 6, over x to the 2nd. Now, x over x is the same as 1 over 1. X over x is the same as 1 over 1. What is left upstairs? 1 times x times x times x times x, x to the 4th on top, x to the 1st, or excuse me, 1 on the bottom, which is just going to give me x to the 4th. Hopefully that indicates a rule for you. If not, we'll do one more. How about x to the 12th over x to the third, what will that be? Again, 12x is on top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over x to the third on the bottom. What's that going to be? Again, x over x is the same as 1 over 1. What's left on top? 1 times 1 times 1, and then 9 more x's. So x to the 9th on top over 1, which is x to the 9th. Notice, x to the 6th over x to the 2nd is x to the 4th. X to the 12th over x to the 3rd is x to the 9th. Subtract the exponents. So if I have x to the m over x to the n, what will our rule be? X to the m over x to the n will be x to the m minus n. If the bases are the same, you can subtract the exponents. Now, that is going to lead to a very important rule for us. What is that going to be? Well, remember, 7 divided by 7 is 1. 10 divided by 10 is 1. X divided by x is 1 as long as x isn't 0, right? So x to the 5th over x to the 5th, something over itself should be 1 again as long as x isn't 0. We can't divide by 0. But we just said with our rule, right? We said x to the 5th over x to the 5th, same base. We should be able to subtract the exponents. That's the same as x to the 5 minus 5, which is x to the 0. And that gives us one of our most important rules, namely x to the 0 power equals 1 for any x other than 0. So 3 to the 0 equals 1. 5 to the 0 equals 1. X to the 0 equals 1 as long as x isn't 0. So that's an important fact for us to look at. So what are our rules that we've looked at here today? Let's remind ourselves of them. If I am multiplying exponential expressions, x to the m, I have m x's in a row, x to the n x's in a row. That will be x to the m plus n. I hope you know why. X to the m raised to the n power is x to the m times n. X to the m written n times a total of m n x's. Then we had x to the m over x to the n, which was x to the m minus n. And finally, anything to the 0 power, right? Anything to the 0 power is 1, as long as that anything isn't 0. Those are our basic rules of exponents.